The responsibility for verifying that plans are followed is a shared responsibility between several stakeholders. Firstly, the project designer, that is, the engineer who designed the plans, is ultimately responsible for ensuring their accuracy and completeness. They should verify that the plans clearly specify any specific requirements or restrictions, such as the required installation method for conduit systems. Secondly, the contractor executing the construction is responsible for following the plans and the specifications precisely. They must ensure that all installations comply with the approved plans. Thirdly, the inspector's role is to verify that the construction conforms to the approved plans and applicable codes. While inspectors are not responsible for verifying the correctness of the design, they must identify and report any deviations from the plans. Let's consider a scenario where the engineer specified that all conduit systems should be installed above ground. However, the contractor installed underground wiring methods, albeit in a code-compliant manner. The inspector's responsibility is to firstly identify the deviation from the approved plans, secondly, report the deviation to the engineer, and thirdly, determine if the deviation poses any safety or regulatory concerns. Based on the inspector's findings, several actions may be appropriate. Firstly, issue a stop work order. If the deviation poses an immediate hazard, the inspector may halt construction until the issue is resolved. Secondly, request plan modification. The inspector may consult with the engineer to determine if a modification to the plans can accommodate the deviation. Thirdly, accept the deviation. If the deviation does not pose any safety or code compliance issues, the inspector may accept it with the engineer's consent. Fourthly, require corrective action. If the deviation is significant, the inspector may require the contractor to rectify the situation by removing the installed underground wiring and installing above-ground systems as per the plans. In conclusion, while each stakeholder has specific responsibilities, it is crucial that all parties work together to ensure that the final construction aligns with the approved plans. Inspectors play a vital role in identifying deviations and communicating them to the appropriate personnel. Engineers should verify their designs to ensure they are accurate and address all relevant requirements. Ultimately, contractors are held accountable for executing the project according to the approved plans and specifications. It's a system of checks and balances to ensure safety and compliance. Deviation from the approved plan can have serious implications for the project as well as public safety. These implications are addressed through the coordinated efforts of the project designer, contractor, and the inspector. The engineer's responsibility begins with a thorough and accurate design. This includes specifying materials, installation methods, and any specific requirements dictated by the project's unique circumstances. It is the engineer's duty to stay up to date with current electrical codes and best practices. When creating a plan, the engineer needs to consider the NEC, or National Electrical Code. The NEC provides guidelines for electrical installations to ensure safety and compliance with industry standards. Engineers typically use computer-aided design or CAD software to create detailed plans that accurately represent the intended electrical system. CAD software allows for precise layouts and clear documentation of all components. The contractor's role involves strictly adhering to the approved plans. This requires a clear understanding of the design documents, proper execution of installation procedures, and continuous communication with the engineer and inspector. Before any work begins, the contractor should thoroughly review the plans and specifications. This review helps identify potential issues, clarify ambiguities, and ensure that the team understands the project requirement. Proper planning and coordination are essential for a successful project. The contractor must coordinate with subcontractors, manage material deliveries, and schedule work to minimize delays and disruptions. It is important for the contractor to maintain open communication with the engineer and inspector. Regular updates and prompt resolution of queries contribute to a smooth construction process. The inspector's role is to ensure that the actual construction aligns with the approved plans and complies with all relevant codes and regulations. This involves thorough inspections at various stages of the project. The inspector needs to have a comprehensive understanding of the NEC local building codes and the approved plans. This knowledge enables them to effectively assess the installation's compliance with regulations. During an inspection, the inspector verifies that materials, equipment, and installation methods meet the required standards. Any deviations or non-compliance issues must be identified and documented. The inspector communicates their findings to the contractor and engineer. If any issues are identified, the contractor is responsible for making the necessary corrections to achieve compliance. In the event of deviations from the approved plans, it is essential to follow a systematic approach. The first step is to document the deviation clearly. This documentation should include photographs, measurements, and a detailed description of the issue. The inspector should then report the deviation to the engineer. The engineer reviews the deviation and determines its impact on the overall design and safety of the system. Based on the engineer's assessment, several actions may be considered. Firstly, plan modification. If the deviation does not compromise safety or code compliance, the engineer may approve a modification to the plans. This modification must be documented and communicated to all relevant parties. Secondly, corrective action. If the deviation is significant or poses a safety risk, the engineer may require the contractor to take corrective action. This may involve removing and replacing the non-compliant installation. Thirdly, stop work order. In cases where the deviation poses an immediate hazard, the inspector may issue a stop work order until the issue is resolved. This prevents further work that could exacerbate the problem. Clear and open communication between the engineer, contractor, and inspector is crucial for resolving deviations efficiently. Regular meetings and prompt responses to inquiries help minimize delays and misunderstandings. Accurate documentation of all deviations, modifications, and corrective actions is essential for maintaining a comprehensive record of the project. This documentation can be valuable for future reference and potential audits. In conclusion, verifying compliance with construction plans requires a collaborative effort from the engineer, contractor, and inspector. Each party has specific responsibilities that contribute to the overall success of the project. Clear communication, thorough documentation, and a commitment to safety and code compliance are essential for ensuring that the final construction aligns with the approved plans. The NEC, or National Electrical Code, serves as a foundational guide for electrical installations in the United States. It is a comprehensive set of standards that aims to ensure the safety of people and property from hazards arising from the use of electricity. Understanding the NEC is crucial for electrical engineers, contractors, and inspectors alike. The NEC is updated every 3 years to incorporate new technologies, address emerging safety concerns, and clarify existing requirements. Staying up to date with the latest edition of the NEC is essential for professionals in the electrical industry. The NEC covers a wide range of topics including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. It provides detailed requirements for each aspect of electrical installations. Article 90.1 of the NEC outlines the purpose and scope of the code. It emphasizes the practical safeguarding of persons and property from hazards arising from the use of electricity. Chapter 1 of the NEC covers general requirements, including definitions, wiring design, and protection. It also includes information on electrical calculations and conductor sizing. Chapter 2 of the NEC addresses wiring and protection. It provides requirements for conductors, cables, raceways, overcurrent protection devices, and grounding systems. Chapter 3 of the NEC covers wiring methods and materials. It specifies the types of wiring methods permitted for various applications, including conduit, cable, and surface raceways. Chapter 4 of the NEC addresses equipment for general use. It provides requirements for luminaires, appliances, motors, transformers, and other electrical equipment. Chapter 5 of the NEC covers special occupancies. It addresses the unique electrical requirements for hazardous locations, healthcare facilities, theaters, and other special occupancies. Chapter 6 of the NEC addresses special equipment. It provides requirements for electric science, elevators, data processing systems, and other special equipment. Chapter 7 of the NEC covers special conditions. It addresses electrical installations in emergency systems, fire alarm systems, and other special conditions. Chapter 8 of the NEC covers communication systems. It provides requirements for telephone, data, and cable television systems. Chapter 9 of the NEC contains tables and examples. It provides useful tables for conductor sizing, conduit fill, and other calculations. The NEC also includes annexes, which provide additional information and guidance. Annexes are not part of the code itself, but can be helpful for understanding and applying the requirements. Proper grounding is essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, which helps to trip over current protection devices and prevent electric shock. Article 250 of the NEC covers grounding and bonding. It provides detailed requirements for grounding electrode systems, equipment grounding conductors, and bonding jumpers. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Article 240 of the NEC covers overcurrent protection. It specifies the requirements for selecting, installing, and protecting overcurrent protection devices. Wiring methods refer to the physical means of installing electrical conductors. Common wiring methods include conduit, cable, and surface raceways. Chapter 3 of the NEC specifies the requirements for each wiring method. Conduit is a rigid or flexible tube used to protect electrical conductors. The NEC specifies the types of conduit permitted for various applications, including rigid metal conduit, electrical metallic tubing, and flexible metal conduit. Cable is an assembly of electrical conductors enclosed in a protective sheath. The NEC specifies the types of cable permitted for various applications, including non-metallic sheathed cable, armored cable, and metal-clad cable. Surface raceways are metal or non-metallic channels used to enclose and protect electrical conductors on the surface of walls or ceilings. The NEC specifies the types of surface raceways permitted for various applications. Electrical calculations are necessary to determine the proper size of conductors, overcurrent protection devices, and other electrical components. The NEC provides tables and examples to assist with electrical calculations. Voltage drop is the decrease in voltage along a conductor due to the impedance of the conductor. The NEC recommends limiting voltage drop to ensure that electrical equipment operates properly. Ampacity is the current carrying capacity of a conductor. The NEC provides tables that specify the ampacity of conductors based on their size, insulation type, and ambient temperature. Short circuit current is the high current that flows during a short circuit. The NEC requires that electrical equipment be rated to withstand the available short circuit current. The NEC is a complex and comprehensive code. It requires ongoing study and training to stay up to date with the latest requirements. Electrical inspectors play a vital role in ensuring that electrical installations comply with the NEC. They conduct inspections, identify code violations, and work with contractors to correct them. Compliance with the NEC is essential for ensuring the safety of people and property. It is the responsibility of all electrical professionals to understand and follow the NEC. Electrical safety is a shared responsibility. By working together, electrical engineers, contractors, and inspectors can create safe and reliable electrical systems. The purpose of electrical codes and standards is to minimize the risk of electrical hazards. These codes and standards are developed through a consensus process that involves experts from various fields. Compliance with electrical codes and standards is often required by law. Electrical permits are required for many electrical installations. These permits ensure that the work is inspected and complies with applicable codes and standards. Electrical inspections are conducted by qualified electrical inspectors. They verify that the electrical work meets the requirements of the electrical code. Electrical codes and standards are constantly evolving to address new technologies and safety concerns. It is important to stay up to date with the latest changes. Electrical safety training is essential for anyone who works with electricity. This training provides information on electrical hazards and how to prevent them. Electrical hazards can cause serious injuries or death. It is important to take electrical safety seriously. Always follow safe work practices when working with electricity. Never work on electrical equipment unless you are qualified to do so. Use the proper tools and equipment for the job. Wear appropriate personal protective equipment, such as gloves and safety glasses. They energize electrical circuits before working on them. Test electrical circuits to make sure they are energized. Lockout and tagout procedures are used to prevent accidental energization of electrical circuits. Report any electrical hazards to your supervisor or safety department. By following electrical safety procedures, you can help to prevent electrical accidents and injuries. Remember, electrical safety is everyone's responsibility.